Hello everyone, I am Ali Farhan and I welcome you all to code with me one question a day. And today's question is find the pivot integer. Okay. Now, given a positive integer n, find the pivot integer x such that the sum of all the elements between 1 to x equals the sum of element between x to n. So the question is pretty straightforward. We have given an n and we have to find an x such that the sum of element between 1 to x is equal to the sum of element between x to n. Okay, so this question is very simple. There is 1, there is x, and there is n. Okay, we have to find x such that the sum between 1 to x inclusive and the sum between x to n inclusive. Okay, this should be equal. So the condition is this. Okay, so the number x should be such that the sum between 1 and x inclusive should be equal to the sum of x and n inclusive. Inclusive means x and n is included in this sum, and 1 and x is included in this sum. Okay, let's take an example. Okay, if we look at this example, there is a number 6, okay, a node 6. That is, if we calculate the sum, 1 plus 2 is equals 3, 3 plus 3 is 6, 6 4 10, 10 5 15, 15 and 6 21. Okay, so we got 21. From here to here, we got 21. Okay, in the same way, if we calculate from here to here, we get 21. Okay, 8 plus 7, 7 plus 6, 21. Okay, so 6 is our answer. Okay, now let's understand the approach. Okay, there are 3 ways to do this question. The very first thing is a linear search, a linear prefix sum, and suffix sum. Okay, the second way is binary search. Okay, and the third approach is the maths approach. Okay, so we will look at the mathematics approach. Okay, so now let's look at the approach. First, we have to understand this thing. If we have to find the sum from 1 to n, we use this formula. This is the standard formula to calculate the sum of n natural numbers. Okay, n plus 1 divided by 2. This is the basic formula to calculate the sum of first n natural numbers. Okay, now let's look at, so the approach is that we will first calculate the sum of this of 1 to x. Okay, we will first calculate the sum of 1 to x, and then we will calculate x to n. Okay, and these will be equal. Okay, right? These will be equal according to the question, right? Why? Because it is given that they will be equal. If they are equal, right? Okay, so we will take it like we will assume that they are equal. If they are equal, then we will get a value of x. We will get a valid value of x. That is, we will get an integer value of x. And if not, we will get the fractional value of x. Okay. So what I am saying is that we will calculate 1 to x. We will calculate the sum of 1 to x, and we will equate it with sum of x to n. Okay, we will equate this. Okay, and we will get a value of x. We will get some value of x. If this x is int, that means it is a valid solution. If we get fractional value, that means that is not valid. Okay, that is not valid. Okay, this will be the correct. Okay, this will be the correct and this will be the wrong answer. Okay, so let's derive the formula first. Okay, let's clear it first. Okay, so now first we will sum up to 1 to x. Okay, what will be the formula? The formula is simple. x plus 1 by 2. Okay, then again from x to l, what will be the formula? Okay, this will be 1 to n, sum of 1 to n minus sum of 1 to x minus 1, right? Sum of, because if you look at this, this is our x. Suppose this is our x. Okay, this is our x and this is our n. So if we have to calculate this, then what we will do? We will simply calculate this entire this. Okay, and we will minus it with this. Okay, so we will 1 to n is this and 1 to x minus 1 is this. Okay, if this is x, that means this is x minus 1, right? 1 to l minus 1 to x minus 1. Okay, so in this case, we will get x minus l. We will get this. Okay, we will get this thing, x minus l. Okay, so let's solve this. Okay, according to the question, these will be equal, right? And we already told the validity of this answer. Okay, if x is integer, then that means is a valid answer, and if x is a fractional value, that means that is not a valid answer. We will return -1 in that case. Okay, let's first solve this. Okay, x comma x plus 1 divided by 2. Okay, we first wrote this. Okay, then this will be equal to this. Okay, this will be equal to this. Okay, so we will add this 1 to l. What's the formula of 1 to n? l plus 1 by 2 minus 1 to x minus 1. Okay, 1 to x minus 1. That means this will be x minus 1 x by 2. Okay, this is x. Okay, if you are confusing, so this is x. Okay, let me write it once again. Okay, so this is x. Okay, so here we can see that 2 and 2 will get cancelled out. Okay, so what we will get, and we will transfer this to this side. So we will get, and we will multiply these two, x square plus x and minus, okay, x square minus x. Okay, and here l plus 1. Okay, this will be plus. Okay, x square plus x square, this will become 2x square. Okay, this will become 2x square, and this x will cancel out. 2x square is equals to n plus 1. Okay, and if we solve this, we get x square is equals to n plus 1 by 2. So this is our derived. Okay, so now what we will do in the formula, we will first find the sum. Okay, we will first find this sum, n plus 1 by 2. Okay, we will first find this, and we will take the square root. Okay, we will first take the square root of this. Okay, if the square root is 8, we return the x. Okay, if it is fractional, we return -1. Okay. Okay, so this is the approach. Okay. So everything sums up to this equation. Okay. X square is equals to n plus 1 by 2. And how it is derived? It is derived simply from this. From 1 to x, this value, summing up from 1 to x, and from x to n, this value. That is from 1 to n minus 1 to x minus 1. Okay, and after solving, we get this equation. Okay, let's quickly talk about the time complexity and space complexity of this problem. Okay, so we are not running any loop. We are simply calculating the sum that is calculated in constant time. Okay, so the time complexity will be O of 1, that is constant time complexity. And similarly, the space complexity, we are not using any extra space. That means the the space complexity is also constant. Okay. So now let's quickly code it in Java, and then we will consequently code with C++ and Python. Okay. Okay. So first we have to calculate the sum. Okay. int sum is equals to n into n plus 1 divided by 2. Okay. Then we will quickly calculate the square root also. Okay. Let's take double, because it may come fractional also. Okay. Double A is equals to math.sqrt. Okay. Sum. Okay. Okay. Now first we have to check if A is fractional or not. Okay. So we will do a simple trick of checking it if it is a fractional or not. A minus math.c A is equals to 0. Okay. This is the way to, because if let's say A is fractional, okay, so let's say 7.2. Okay, so 7.2 minus math.c of A means 7. 7.2 minus 7, that means we will get 0.2. Okay, which is not equal to 0. That means it is fractional. Okay, if it is satisfied, that means it is an integer value. Then we will do this. Otherwise, we will simply return -1. Okay. Otherwise, we will return the value A, and that too we have to return it after typecasting it to integer. Okay, so this is how it does. And let's quickly run it. Okay. Okay, it works. Okay, it works fine. It beats 100%. Okay, now let's quickly code it in C++ also. Let's quickly copy the code. Okay, int sum, and okay, this is same math.sqrt. Okay, so here it is sqrt only, and here it is math.seal only. Okay, and this thing is good. Okay, let's run it. Okay, it is working fine. Okay, let's quickly code it in Python as well. Okay. Okay, I copied the Java code, and I will make necessary changes here. Okay, and double A it is okay, and this is small a, this small m. Okay, and here it is not required. Here it is not required. Okay, math.seal m is small. Okay, this is not required, and return int A. Okay, here we have to do this. Okay, now it is good. Okay, now let's run it. Okay, I forgot. It is int. Okay, now it is good. Let's run it. Let's hope it works. Okay, it works. Okay, let's submit it. Okay, so it is submitted. Okay, so thank you so much. If you have any suggestion for me, please comment it below, and we will see you tomorrow with the next question. Thank you so much.